Problem solving, limits with graphs. Before we begin our first problem solving section, let's go over some of its expectations. Problem solving sections are a required portion of the course, and it's not advised to move quickly or skip over these sections. These sections include tested content knowledge. You're going to encounter problem solving sections within each unit, and you are encouraged to work diligently on these sections as they often mimic AP-style questions. It can seem very overwhelming to think about all of the possible strategies that can be used for limit questions. Hopefully, the next few slides will provide you with a game plan to approach limit problems with confidence. Questions involving limits and graphs will usually ask for the limit of f of x as x approaches a from the left. When this occurs, follow the graph towards a from the left, and your answer will be the y value or function value as you reach the x value of a. You could also have the limit of f of x as x approaches a from the right. So follow the graph towards a from the right, and your answer will be the function value or y value as you reach the x value of a. You could also have the limit of f of x as x approaches a. In this situation, follow the graph towards a from both sides, meaning from both the left and the right. If you end up at the same y value or function value, then that is going to be your answer. If you do not end up at the same function value or y value, then the limit does not exist. If you have f of a that you are looking for, then find the y value or function value that corresponds to the given x value of a. And the last option that's listed here is the limit of f of x as x approaches a is equal to f of a. If the question asks for continuity, then make sure that the limit exists and the function exists at this a value and that they are equal to one another. Let's try an example. Use the graph to determine the function being evaluated at -2 or f of -2. We're going to find the limit of f of x as x approaches -2 from the right, the limit of f of x as x approaches -2 from the left, the limit of the function f of x as x approaches -2, and then determine is the graph continuous at -2. We're going to start off by evaluating the function at the x value of -2. Well, if we look at the graph, when x is -2, the function is assigned this value, represented by the closed dot or closed circle or closed point, which is at -1. So f of -2 is equal to -1. To determine the limit of f of x as x approaches -2 from the right, we can follow the path of the function as it's approaching -2 from the right, and we can see that the function is approaching a y value or function value of 4. So it's equal to 4. For the limit of f of x as x approaches -2 from the left, we can see that as x approaches -2 from the left, the function approaches the y value of 4. So therefore this limit is equal to 4. For the limit of f of x as x approaches -2, we approach the same y value or function value from both the left and the right, and that value is 4. So therefore the limit of f of x as x approaches -2 does exist, and it is equal to 4. Now, is the graph continuous at -2? The answer here is no, because the limit of f of x as x approaches -2 is 4, and the function evaluated at -2 is -1. These two values are not equal to one another, so therefore the graph is not continuous at the x value of -2.